Okay, so this is going to be the last set of notes that we're going over for today, March 24th's lectures. These are from March 6th, and it says Heating and Cooling Curves, Part 3, Summary and Practice. So this one is going to be much shorter than the others because I expect you to go through these and use them as practice, right? So I'm going to go over the first few here, and then these questions, which were used to make your quiz. I want questions about those. I want specific ones that you guys need explaining. And I think I have a few. I wrote them down somewhere, the ones that were commonly incorrect on the quiz. I think I put those on a worksheet also. But, okay, so let's start going over these. Where is it? Okay, so we're going to go back to my little cat example, right? I do this a lot. The cat's laying there and I stick my feet under the cat because my feet are cold, the cat's warm. Which direction is the heat flowing? Right? We have cat is hot, feet are cold, and the cat is warming my feet. So the heat from the cat is entering my feet, making them warmer, right? Heat. By the way, this is not my cat, and these are not my feet. Same up here. Not my cat, not my feet. Okay. By the way, the extra credit, you could still do it. I don't care. It's, throw some extra points on there. Also, the offer still stands that if one of you make a chemistry video, but you're going to have to make it by yourself because you should be in your house alone. You could definitely involve your siblings. I don't mind. And your pets, whoever. Just do not invite your friends over because we are inside, right? Social distancing and quarantine does not mean go out and hang with your friends, right? Even if you're making a chemistry video. That being said, if one of you makes a video and posts it, I will post my high school video that I made in high school. Okay. And last night's homework, again, you're supposed to do that as practice. Check yourself against the answer key, and whatever doesn't match up, I want you to ask me about it. I will totally explain, but you need to give it a try yourself. And then, if anything, we could talk about it. And here is the answer key, right? It's on the website also. Okay. We talked about this in the last video. You guys need to read, right? It said solid there. Look alive. Look at those phases of matter. Okay. All right, here now we're actually on the notes part. Okay. So I did the do now. Great. High to low. Okay. So looking at the heating curve completed in class and the cooling curve completed for homework, assuming they're the same substance, what do you observe about the temperatures at which melting, boiling, freezing, and condensation occur? So I wish I had these pulled up, but if you take a look at those two sheets, you can see that the melting and the freezing occur at the same temperature, which is, I'll pull it up now, 50 degrees Celsius. So on the first graph on page 3, the melting occurs at 50 degrees Celsius. Go over to page 4, the freezing, right, from D to E also occurs at 50 degrees Celsius. So it's the same thing. Melting and freezing occur at the same temperature. And on the other hand, right, when you're talking about liquids and gases, boiling and condensation happen at the same temperature, right? This is super important because, and it's true for all substances, you're going to get questions like this, right? So this is, let me pick one, condense, right? So if you did not know that boiling and condensation happen at the same point, you would read this and say, at what temperature does nitrogen condense? And then you'd, go over to your reference table and you'd look at it and you'd be like, oh my God, wait, it only has boiling and melting on the reference table. How am I it doesn't say it. Am I supposed to memorize these? No. You're supposed to know that boiling and condensing are the same thing, right? So what temperature does nitrogen condense? That is the same as your boiling point. Freezing point, right? There's no freezing on table S, but freezing is the same as melting. Melting point, all right, great, we have that. Change from a solid to a liquid. What do we call it when you go from a solid to a liquid? Melting, right? So the melting point's on there, great. Boiling point, again, we have that. Solidify. What does solidify mean? Solidify means you're going from a liquid to a solid. What do we call it when we go from a liquid to a solid? Freezing. Okay, and that is the same as your melting point. Bromine gas changing from a liquid to a gas. Liquid to a gas, we call melting. That's on there. Boiling, sorry. Great. And change from a gas to a liquid. What do we call it when we're going from a gas to a liquid? It's condensation, which is also same thing as boiling. Great. So these are major keys, right? You need to know that they're the same thing, or else you will go through what I described, which is, oh my God, they only have the melting and boiling points on table S. Am I supposed to, freezing, condensing, am I supposed to know those? Am I supposed to memorize all that? No. You just have to know that melting and freezing happen at the same temperature, boiling and condensing happen at the same temperature. Okay. Heat transfer, right? We're talking about the kitty foot warmers again. I'm sure some of you have seen this. Pets like to lay on tile floors. My cats go and lay in the bathtub in the summer because, they're wearing big fur coats all the time that they can't take off. They want to cool down a little bit. They lay on the tile. The tile's nice and cold. So the heat energy is going, now it's reversed. The cat was the warm one before, and it's still the warm one. If it is laying on something cold, that means the heat energy is going from the dog or the cat to the nice cold floor tiles. So that means the dog or cat is losing heat and the floor is going to be gaining heat. And then if I have a glass of soda at room temperature, like, you go to the grocery store and it's sitting on the shelf and you open it, pour it in a glass, you put some ice cubes in it, right? Are the ice cubes hotter or colder than the soda? Colder, right? Ice cubes are colder. So when I put the ice cube into the soda, the heat energy is going to go from the soda to the ice cube, meaning that the soda is losing heat energy and the ice cubes are gaining heat energy. Okay. This one I'm not going to go over because we should be pretty familiar with those by now. My recommendation is that you give it a shot, do it yourself, right? Fill these in, and again, check the answer key. If something doesn't match up, ask me about it. Write that down, put it on your Ask Miss Perley list. These ones, I'm not going to sit and go through all of them, like I mentioned. This is yet another excellent way to test yourself, right? A lot of us should have done that before the quiz because I gave you the answers to the quiz before I gave you the quiz. So I've said it a zillion times and I'll still say it. You have to test yourself, right? Test yourself to see what you don't know. So go through these, try them again, check your answers. If your answer is wrong, ask me why, right? And lastly, the summary. All right, a heating cooling curve can be constructed to illustrate the phase changes. Good, that's what they're for. The kinetic energy and potential energy thing, right? When we're looking at them. So we'll go over that again one more time. All right, so I have From A to B, I have a solid. From C to D, I have a liquid. And from E to F, I have a gas. And we'll take a look at that. The slanted parts, right? They're not flat, they're not straight up and down, slanted. Those are where we have one phase, right? Temperature's changing. It's going from 0 up to 50, definitely change in temperature. Where we have changing temperature, we have only one phase. And temperature is a measure of the average kinetic energy. So when the temperature is changing, the average kinetic energy is changing. Now we look at the flat parts of the graph, right? From B to C, D to E. B to C, we have both a solid and a liquid, right? Solid, liquid. Between D and E, right, we have a liquid and a gas. So we have liquid and gas. And again, average kinetic energy is the temperature. So if the temperature isn't changing, then the average kinetic energy isn't changing. But we're adding heat. So something has to be changing with the energy, right? Because heat is a form of energy. The potential energy is what's changing at these parts. So change in potential energy, change in kinetic energy. Okay. All right, so that concludes all the video lectures for today. Write down what you're confused about, let me know, and we will talk about it during our extra help session. All right, I look forward to seeing you guys. Bye.